Hi, everybody. You are listening to another episode of Living with Lyme, and we have a special guest today. We have Dr. Kara Fitzgerald, and we're going to talk about a very complicated issue of methylation. But first, before we get going, I do have a few shout outs that people wrote into me. The first one is to Michelle and Ken Miller from Central Mass Lyme Foundation, and it was from someone named Becky, and it was for love and support. I have another shout out to Dr. Neil Spector, an anonymous one. It was a mom who got so much information out of the book that really helped her son dealing with Lyme and his heart. And the last one is to Jen Corey for healing vibes. From her friend Cindy. So I thought that was awesome, and keep the comments coming in. It's really happy. You can go to www.livingwithlyme.us, slide down the page, and you can email me. Anyways, let's talk a little bit about Dr. Kara here. She is super educated. She has quite the affinity for methylation. We're going to find out all about that. She is a naturopathic doctor. She is an author. She also is the host of New Frontier in Medicine, which is her own podcast. And we're flipping the tables on her today by having her as the guest. Welcome, Dr. Kara.
Thanks for having me on, Cindy. It was really, I'm glad you reached out to bring me on, and it just sounds like you have a fun audience, a great audience. You're doing a lot of good work. And so,
thank you.
I look forward to talking to folks about, this area that I'm particularly interested in, and see if we can be of any service.
Right. It's kind of, it's very complicated, and it has a lot of impact to our health. Even for people who are fairly healthy, it has a big impact. So what's your obsession with methylation?
Well, so my obsession with methylation is specifically related to how it impacts genetic expression. We turn genes on and off via methylation. So these little, a methyl group, if everybody remembers back to chemistry in high school, it's a carbon and 3 hydrogens. That's a methyl group. And we actually put these methyl groups on certain regions of our DNA. And when we do that, by and large, it inhibits expression of that particular protein. So let's think about things that we want on, and then the absence of methyl groups will allow that protein to be on. So protein, you say, and you scratch your head. What does that mean? Like the hamburger I just ate? That's protein. Well, proteins are kind of the workhorse. We make millions of them in the body, and they're sort of the workhorse animals, and they go around and do a lot of stuff. So some proteins are some proteins, muscle is a main protein. Our heart is a giant muscle. Proteins can be involved in inflammation. Proteins can be involved in quenching inflammation. Proteins can be involved in driving cancer, in driving cardiovascular disease, or conversely, turning it around. So methylation, DNA methylation, is very intimately involved in regulating that activity. And this DNA methylation is at the interface of our genetics, our life experience, and how we influence the expression of our genes based on what our life experience is.
So there's a big purpose to this.
Yeah, it's really important. If we want to live our best life, some attention should be made to how our genes are expressing, and can we optimize that?
It's a new wave in medicine, and I have said now for a bit of time that in the future, and it's probably not too far away, that when a baby is born, that they will actually find their genome, their personal genome, and then provide them their health care through that. And I think maybe in the future, we're going to be able to keep our kids healthier because we're going to be able to find out where their potential weaknesses are. I mean,
Yeah.
your genetics are impacted again by, you know, what you're eating, your environment, what's around you, what are you
Yep.
getting exposed to?
Toxins, our stress. I mean, stress has a massive influence. Fear, whether you're getting a lot of love, whether there's an absence of love. I mean, just all of these environmental exposures, toxins, et cetera. I think you said that can influence DNA expression. Yeah, and so we want to figure. Yeah, how do we optimize that? How do we make it impeccable? You know, not just for us in real time, not just so I can live my best life or you can live your best life, but if we are preconception, if we're going to be making babies for the mom and dad, preconception for the future of those kids. I mean, what we know about this epigenetic, this DNA methylation, is that it's heritable. We can actually pass down, whether we're living our best life or not, to future generations. And it is a big deal. And Cindy, the fact of the matter is, being able to optimize that is now. Like we don't need to wait for sophisticated testing and, tricky, expensive medication and various tools. Optimizing that, not just for us, but for future generations, we can do that now.
All right, there you go now. How are you going to do that? How are we going to do that?
Yeah, well, I want to just say something interesting as an aside. Some really good friends of mine over at Grow Baby. You can go to, I think it's growbaby.com or growbabyhealth.com. Leslie Stone and Emily Ridbon. Leslie is a OBGYN and Emily is a nutritionist, and they've been working together. They're a mother-daughter team. Actually, Michael Stone is over there as well. And Leslie has delivered thousands of babies. And Emily works preconception and then during pregnancy on the nutrition angle of things. And really one of the cool, I just podcasted with these guys so people can take a listen to it. They're using the methylation program that I've designed with these pregnant women and in preconception. And so the reason that I'm bringing it up now is that embryogenesis, when you've got that little embryo that's going to grow into a human, that is a hotbed of methylation activity, of DNA methylation activity. That is, so that little embryo is busting out all sorts of new cells. You're going to, through methylation, you're going to define whether or not that's going to be a bone cell or a brain cell or a heart cell or a gut cell. So methylation is really telling the genes what to do and what to make. And it is just a nuts hotbed. That's real. That's one of the reasons why when we're pregnant or before we're going to conceive, we start taking a folate supplement so that we can have that. We're swimming in a methylation soup and we need that optimal. Exquisitely important at that time is diet, is a folate-rich, B12-rich, methyl donor-rich diet. And there's a whole lot of other pieces too. So I just want to circle back on some basics on methylation. You had earlier, before we started recording, you showed your complex pathway. But so in order to make methylation happen in the body, it requires a healthy methylation cycle. It requires certain nutrients like B12, like folate, like something called betaine, which we can get in beets. Choline, we get lots of choline in eggs. We need minerals. We need zinc. We need magnesium. We also need B6. We need amino acids like methionine, taurine. So there's just a host of micronutrients that help this methylation cycle spin. And then there's a whole nother host of micronutrients that help regulate at the DNA what proteins are turned on and what ones are turned off to optimize. And those are things like curcumin and green tea, which I'm actually sitting here drinking now, rosemary, luteolin or lutein in tomatoes, blueberries. A lot of our really beloved favorite foods have this ability to really optimize balanced DNA methylation and therefore genetic expression. And, again, we can go all the way back to, preconception and early embryogenesis on out. So once that embryogenesis period is done, why do we need to continue to think about it? Well, it turns out cancer is always informed by aberrant or abnormal DNA methylation. There's way too much over here. There's not enough over here. It's like this mess. And when you look in the science, you see not only cancer, but you see cardiovascular disease, or you see patterns with autoimmunity, or going to the gut. We see that the gut microbiome can disrupt things. So through life, we need to be thinking about how to support and optimize this balance expression so we can live our best life. In fact, I'm going to say one other thing, and then I'm going to hush so that you can take over, Cindy. When we look at aging, when we look at the aging process, that is a process of generally being less effective at methylation. And there's a cool epigenetic clock, biological clock, where we can look at one's biological age and see if it's, way older than their their clock age, their birthday, or not. And that is an epigenetic analysis. So we can look at how the DNA methylation is functioning, and we can see if somebody is aging before their time, or they are super well preserved and fabulous. And that is, just another piece that we want to consider. It's another reason why we just want to be invested in, how we do this and do it right. Okay, Cindy, take over.
All right. So telomeres, is that what you're talking about? Identifying? No.
No, in fact, actually, so telomeres shorten as we age. Telomeres are a marker of cell division. So more and more cells divide. The telomeres shorten, and the cell and the body are aging as you look at telomere length. No, the epigenetic clock, as created by Steve Horvath out of UCLA, he's a biostatistician, research scientist, is more sensitive, more closely associated with the aging process than tracking telomeres. Okay. So soon we will all be talking about this, the epigenetic clock. Telomeres are still cool and still something to think about, but when we look at statistics in science, the epigenetic clock is actually more closely associated.
Is there a way to test for that? Is there something?
Yeah, there is. Mm-hmm. Yeah, yes, there is. Yes. So you can actually, there's a test direct to consumers. I'm not a part of this company at all. It's called My DNA Age. It's actually My DNA, and then that A in DNA goes to make age. So I think if you go there, you can put a link. You can just put a link on your show notes if you want to. I have no involvement with them at all, but they are running the Horvath panel.
My DNA. Where they are. My DNA dot.
Probably com.
Just a com.
If you just Google My DNA,
sure.
You'll find it. Yeah, it's easy.
Yeah. Well, it's not just one set of genes. And again, Emily Givler, who did a podcast with me, she works alongside Bob Miller. The most important thing about your independent genes and your possible variances is they're predictors, but they're not necessarily an indication that something is going to happen. But knowing those areas of what I'll call them weaknesses, we can then utilize more strategies. So, let's get back to what you said about understanding and then going ahead and supporting your methylation regardless of your DNA. Are you saying that it's not even necessary to know your DNA just to go, forward with optimizing whatever you have?
I would say, given a choice right now, I would be more interested in understanding my epigenome than perhaps my DNA. But so knowing our genes, I guess single nucleotide polymorphisms, that's what everybody is looking at when they order a 23andMe or an Ancestry.com, some kind of analysis like that. They give us millions of single nucleotide polymorphisms that by definition aren't super significant. Like we've all survived the various genetic mutations. Like they haven't shut down the species. So by definition, you can have that mutation and it doesn't kill you. You can pass that mutation on and it doesn't kill you. It might switch your requirement for certain things. Maybe you need a little more nutrient, a little bit less nutrient, but they're not, I think that their importance has been overstated. I do think, though, in the future, we'll be able to analyze a lot of those SNPs in the context of perhaps the epigenetic stuff that I'm talking about. Like we'll have a bigger ability to look at a lot of variables at once and then make meaningful decisions. So in the meantime, I don't know. Like when I look at, I see a lot of genetic data. People come to me all the time, and it doesn't change how I treat them unless I see a sign. You know, I wouldn't say if the MTHFR mutation, I wouldn't automatically start taking folate or B12 until I actually get them look and see whether or not you have a need for folate and B12, in which case then we'll consider adding it as a supplement. Even better, if you can get your folate and B12 and all of your methyl needs from primarily dietary sources, I think then for a number of reasons that is just fabulous.
My practice as a nurse practitioner and my registered dietitian, who happens to be my daughter, so it is a mother-daughter thing going on here as well. I always look to her to say, okay, after I see people for that kind of medical aspect of it and do some testing, whatever is necessary, she's the one that really puts them on a goal to create their best nutritional needs. And the one thing that always worries me that I typically don't tackle with her is, geez, if you're going to need your methylated Bs out of your diet, how much are you going to need to consume to get your B6 or your added B12? And then we always have to worry about GI inflammation causing decreased absorption. And when there's decreased absorption and now you might be taking more but you're not creating, do you look at that?
So I'm going to talk to you. I'll talk to you about it. Yeah.
Okay. Talk to me about it. Talk to me now.
I actually want to jump back. I originally started this conversation mentioning Leslie Stone and her daughter Emily and their Grow Baby work. So they're using this methylation approach that we outlined, and their birth outcomes are just remarkable.
Really?
Remarkable. Yeah, the incidence of autism, preemies, ADD, ADHD, etc. The incident of early childhood developmental issues is almost nil in that extraordinary practice. And one of the pieces that they're doing is optimizing this epigenetic expression. In fact, that's a big piece, and they've been using our program in a part of it. They're doing other things too, so I want to make that clear that it's not just us, but it underscores the importance here. So swinging over to you, why diet and not, and can you even achieve enough? I think when supplements are indicated, they're indicated. You use them. So remember, go back in time for a second, Cindy, at the very beginning of our conversation, and I talked about too much methylation happening on the genome and too little methylation, and we call that aberrant or differential. It means that, like in cancer, for instance, cancer has so many regions of hypomethylation. So the DNA, if you look at the gene, you'll see that there's all sorts of methyl donor marks missing, but then you'll look up and you zoom in even closer and you'll see some are hypermethylated. So for instance, tumor suppressor genes, classically say BRCA or P53, right? These massive proteins that really help snuff out cancer before it turns into anything significant. Well, sometimes they're hypermethylated and shut off. Or our detox genes, like glutathione transferase, you might have a mutation in it or it might be working fine, but sometimes the microenvironment can shut it down. Conversely, genes that we don't want turned on, say like NF-kappa B, the major sort of driver of all things inflammation, might be hypomethylated and turned on. So one of the pieces we want to think about with this work is this balance. And the best way to achieve balance is to give the information for optimal genetic expression in the form of food, and foods that both support putting methyl groups on, so methyl donor intense foods, but also helping to remove them or keeping them from popping on when we don't want them. So it's this big balanced picture. It's not just, let me give you, a B complex, or here's some B12 and folate, or here's a bunch of betaine. It's beyond that. It's like there's a more, it's a little more subtle, a little more sophisticated, and a little bit more broad, because what we understand from the literature now is that both hyper and hypo can happen, and both can be associated with disease, and so we just really want to finesse it. Now, in my practice, I'm a practicing physician as well. I prescribe supplements all the time. If I'm worried about malabsorption, as you've said, or if I see really profound deficiency of B12, maybe they've got macrocytic anemia or something very obvious, or their homocysteine is terribly high, yeah, without question, we're using supplements. I guess my argument, though, is for really sophisticated, a sophisticated massage of genetic expression that could influence longevity and just have its course in so many different variables. This broad upstream approach, I think, is indicated.
So how do we know if we're under or over methylating?
Well, so there's two different, so the terms under and over methylating, I think where you're talking about kind of come from the Walsh school of thought, Bill Walsh. Is that right, Cindy?
Let's say yes.
Okay. The reason I'm asking you is that there's a difference between thinking about DNA and methylation on DNA, and then biochemical methylation. I know there's a lot of talk on the web about, am I an under or over methylator, and what do I need to do about it, and what are the symptoms associated with that? That's a different thing. That's a different conversation than talking about the genes.
Okay.
Okay, it's a whole different avenue, and quite frankly, it's just different from this discussion. In this discussion, what I would say to you is that we've got, we all have imbalances. I mean, the age, sadly enough, the process, as I cross the threshold of 50, the aging journey is one that lends to hypomethylation, so less effective methylation. And we know, as we age, our homocysteine tends to go up, and that's like a fundamental marker of how well you're methylating, so that's a common thing. But even as things move towards less methylation, there's still those pockets on our DNA that can be hypermethylated and problematic. So both are occurring.
We look at homocysteine, and we know that elevated levels are certainly an indication of inflammation. And we look a lot towards probability of cardiac disease with that.
Mm-hmm. Yep, that's where it was originally researched. Yep.
And, we look at, the listeners here are most of them are dealing with Lyme disease, and they may not know at all about methylation and the process of the methylation, and looking at our DNA, just for the simplistic part of our DNA. We know that we can have some SNPs or the variances to utilize from our diet, whether it be in supplementation or in our food sources, being able to process and utilize the methylated folates. So with that, and I know we're talking a lot about the genetic expression, et cetera, based on our own DNA. Can you talk to some about your people's independent genes that can be a problem? when we're talking about being heterozygous or homozygous for MTHFR, which I understand that we're not completely talking about, but I want people to have some association with why you're able to take in vitamins and process this in your whole genetic realm and your diet as well, because certainly diet is fundamental.
Um, so what do I want to say?
Well, I think what you want to say
Yeah,
is
tell me what I want to say.
wait, this is what you want to say. You want to say that almost at least 45% of the population do have a variant in their MTHFR gene. Now, there are a variety of genes that are kind of under that umbrella. And, that impacts a lot of the way that we are able to process our B vitamins. I want to say that you want to say that that folic acid is synthetic. It's added, folic acid is, added to my whatever, my cereal or my bread. Well, that's not what we're necessarily talking about. We're talking about utilizing folate either from our diet or supplements. We have to convert it in our body and into the working part of that. So that's where that nutrition comes in.
Okay, I hear what you're saying now, Cindy. Okay, yeah, that's a fair point. Yeah, so I don't think, I would not recommend the ingestion of the synthetic folate or fortified grains. I would not. However, if that's all you have, most of us will absolutely activate it without an issue. So I don't want to be too. I mean, you can, we don't activate it as efficiently, and some of us activate it less efficiently than others. So natural folates are relatively easy to get, and so we can do that. And incidentally, in a healthy gut, in a healthy microbiome, we make plenty of folate, B12. We make some really fabulous players in our gut, and that is a important and necessary reservoir for for the various places in the body where we use folate and B12 and so forth. So where are we?
That being
Let
said,
me just
okay,
finish that
go
thought.
ahead. Go
Let me
ahead.
just finish that thought. So it is true, if you've got a host of single nucleotide polymorphisms in methylation cycle and your ability to make your various, S-adenosyl methionine ultimately, if you've got mutations in that cycle and you're not making things as efficiently, then you need an extra leg up. Yes, that's right. And it may be through supplements and it may be through diet. I mean, it can be either, or it can be a little bit of both. So it is true that those mutations, they're common. We don't want to overstate them, but they can change your demands. I mean, that's individualized nutrition, isn't it? Individualized nutrition is sort of knowing your flavor and what's going to make you tick and dial in optimally.
Right. I think people underestimate the power of what they're consuming. You just said you're sipping on green tea. People don't realize that green tea provides you with a lot, the antioxidants and
Yeah.
just, yeah. And
It's actually really potent and important information for DNA methylation. It really is. It
okay,
helps
how
to
so?
augment it.
Okay.
Well, interestingly, so again, going back to cancer, because it happens to be the best researched area, DNA methylation, there's just a ton of it. And that's because the tumor microenvironment can take over the epigenome. It can take over how our DNA is expressing and manipulate it. So in the tumor microenvironment, we can hypermethylate and shut down really important genes that fight cancer. So the cancer itself can shut down genes that the body fights, uses to fight the tumor itself. And green tea has been demonstrated to be able to reverse that and liberate those previously hijacked genes. And that's probably a big reason why we always prescribe green tea as an important workhorse in any cancer protocol.
Oh, that's true. That's true. What I say is, especially if you're in a warm climate, get some organic green tea. You can either get it loose leaf, or certainly you can get it in bag form. And you get your big glass container, not plastic, people, a glass container. You fill it with your filtered water. It's got to be filtered. And you put an appropriate amount of tea bags in there. It depends on the
Yeah.
size. And then you put that cap on and you put it outside in the sun for a few hours. And now you have wonderful brewed green tea. And your choice is either to, leave it at room temperature. I certainly like it and I prefer it iced, and I love it with a little bit of lemon essential oil, good quality essential oil. You can also flood it with your own fruit. That type of, that's an easy thing to do for yourself instead of,
You could do, I'll tell you what, if you wanted to make something that would be super nourishing to DNA methylation, you want a nice, yummy summer drink, well, I would do green tea, and then I would, just macerate some blueberries and dump that in there for the fruit that you mentioned. And if you wanted to just pound a little bit of rosemary for a little bit of a kick, all three of those are what we call methylation adaptogens. And that would be a really delicious sip on all day summer cocktail or beverage. And I guess if you wanted to bump it up to cocktail status, you could probably throw some clean, a little bit of clean, potato vodka in there or something.
Yeah, you can do that. You can do that.
That's actually not great for DNA methylation, the potato vodka. At least the other things would be kind of preserving you a little bit.
I wonder if it's a balance then.
Yeah, it would help.
So extra blueberries, everybody, extra blueberries.
Dump them right in your green tea. I think we can make available to you some of our favorite, some of the favorite foods that we recommend, and people can get into the habit of snacking on them. Hang on, let me show you something. So in my office, I've got this rosemary. So rosmarinic acid in rosemary, you can certainly get that as an essential oil, is a powerful, what we call methylation adaptogen. That means it helps that suppressed important gene. This will help, bring it back to life, so it's back on again. In addition to the green tea, curcumin, lutein, what else?
I mean, all of this is great. I mean, I do know people have palate issues with certain things. Like I have a really good friend, Melinda, I'll give you a shout out there. She hates tomatoes. Okay, well, you hate tomatoes, but there are other things that can take its place. Like, it's funny because somebody told me recently they hate blueberries. And I'm thinking to myself, how do you hate blueberries? And then my daughter, Kara, she's a Kara too. She says, you got to try something 9 times. And if you can get through the 9 times, most likely you're going to like it. And if by 9 times you don't like it, well, I guess you're going to give up on that one.
Well, and it depends. You can get bad blueberries, right? Like sour strawberries. I mean, if you get blueberries out of season, they can be terrible.
Yeah.
So,
yeah.
Anyway, so listen, what else have you got for me? Are we coming to our...
Oh, God, no. We've got so much. I can't even stand myself. Let's talk about energy production. We know that methylation has a lot to do with cellular changes. So what about our energy level? I don't know. Can you hear that flyover?
Mm-hmm. Yeah, a little bit.
Yeah. So my little town is Wilbraham, and we are not too far away from Chicopee, and Chicopee is where Westover Air Force Base is. Mm-hmm. And that's a fly-in, and sometimes we hear them and sometimes they don't bother us. It's not a constant thing, but it's a shout out to all our people in the armed forces. Before we go on and before I ask you another question, I do want to tell everyone who is watching our video here that I've been very fortunate to have support from Hopkinton Pharmacy, from Biobotanical Research, and from Master Supplements. So if you could show them some love, you can look at their websites and maybe do some ordering. I really appreciate it. And they appreciate it as well. So, to get on with our methylation, and I just asked briefly about energy. And is there something you can comment about our methylation processes, enhancing them to the best of our ability, and what it's going to do for our own energy?
Well, it's interesting that, if we think about, I'm going to just create for the sake of our conversation, these two areas of methylation. There's the biochemical methylation, and then there's this genetic or epigenetic space. So if we think about biochemical methylation, of course, we know we need a methyl donor, we need functioning methylation, healthy methylation activity to make adrenaline, noradrenaline, to make all sorts of energy involved compounds, things that help with our get up and go and our mood and our desire to engage in life, etc. So we need healthy methylation there. Interesting with regard to genetics is that we need good, vibrant mitochondria where we make our energy to fuel good DNA methylation. So compounds that we're generating in our mitochondria are essential to good genetic methylation. So in our program, that's one of the pieces that we're considering and that we're optimizing. So, and mitochondrial function has to be like, as good as possible to support it.
Right, right. Who made us, truly? If you think about this and how we came to be, no matter what area you believe, Big Bang Theory or, the religious theory or whatever, we are so complicated. And, genetic determination and our environment impacting that. What happens? Let's talk about our environment a little bit, because we are living in a huge toxin area. We've got petroleum products, we've got our grains, and even the crops next door that have glyphosate. And we talk about mold, we talk about heavy metals. How is all that impacting our ability to protect our DNA so that we have real, tell us more about that.
Yeah, the burden of toxins influences at every step. So it can influence the DNA methylation that we've been talking about, but it can just really wipe out DNA directly. It can damage the genes directly. It can alter genetic expression powerfully, and then it can, of course, gunk up the metabolic works elsewhere and shut down, just compromise methylation elsewhere. No, and we use methylation to detox the body. We need a functioning methylation cycle, not just to detox via methylation, but to support the all-important antioxidant glutathione and the detox pathway sulfate, using where we use sulfur, the sulfation pathway. So functioning methylation is required for so many levels. And yeah, toxins interfere quite profoundly. There is interesting research out there. This isn't an animal model, but they exposed mice to BPA, kind of an evil it's ubiquitous, where all of us are exposed to BPA on a daily basis, and most of us have a body burden of it, and it's an endocrine disrupting toxin. So they exposed pregnant mice to BPA, and then they gave them methyl donors in their diet, sufficient folate and B12 and so forth. And the impact of the BPA was negated by having adequate methyl donors in their diet. So they showed that. So toxin exposure, but sufficient methylation support really turned around and negated the toxin exposure and the offspring. And they actually
did they compare it to those that were not given that type of a diet?
You know what? I'm sure that they did, and that they didn't survive. And I'm so sorry, I don't have that top of mind, but
that's
we
okay.
Can, well, actually, no, I do have the answer. So hang on a minute. I do have the answer. So it's a little bit more involved. I'm so sorry. I'm sorry.
Why are you apologizing?
No, just because I should know that I should have the study like in the back of my head. But let me just walk you through it again.
Okay.
So in this model, it's showing the effect of methylation on offspring, and they're called agouti mice. So these mice are born blonde, and they're actually really fat. They're very overweight, and they grow up, these agouti mice grow up to develop cardiovascular disease and diabetes and so forth. And when you look at them visually, they are blonde. I mean, they're such a distinct looking mouse. So what Randy Girdle did, what he figured out in his laboratory, was that the reason that they look this way is because because this one gene is on. This gene is turned on, and if it were turned off, if it were methylated and shut down, they would in fact resort to looking like every other mouse, a skinny little brown thing, right? So they did a couple of experiments. In the first experiment, they gave pregnant mice adequate methylation. They give them extra methyl donors, extra folate and so forth in their diet. And those mice gave birth to healthy brown mice who weren't obese, didn't have risk of cardiovascular disease, etc. So that was experiment number one. And I want to tell you that that experiment is, that paper is the most cited paper in the history of science. And I actually have a podcast with him. His name is Randy Girdle, but it's outrageous. It was an incredibly fundamental, huge, important study because it showed the profound impact of diet on outcome, on health, on what they call phenotypic expression, on diet influencing genetic expression. Boom. Randy Girdle and Waterland in their laboratories showed that in spades. So that was study number one. And then what they did was expose BPA to mice, and that the BPA, yeah, I'm not pulling the threads, but the BPA exposure turned on the agouti gene, and they were obese again and blonde. The BPA exposure allowed the agouti gene to be fully expressed, so obese, blonde, at risk of heart disease, and so forth. And then I'll just have to fine tune this in my brain again a little
that's
later.
okay.
But
That's
then,
okay.
so let me just keep listening. So
Okay.
then the next batch of mice, they gave them the BPA, plus they gave them the methyl donors, and those mice were fine. They lived. So the impact of the BPA on their genetic expression was negated by having enough methyl donors.
That's important. That's extremely important because that has to do with everything that's that impacts us in life. And you know, for our Lyme listeners, that's critical. What you're saying is, you know, some of the Lyme people are treated, yet they go on to have chronic issues, and some of those chronic issues may be because certain genes have gotten turned on. Do you
That's
feel
right.
that way? Yeah.
Yep, that's right. Yeah, absolutely. Well, certain genes are on and certain genes are off.
Right.
So yeah, definitely. There's, you know, this is a little bit tangential, but it is ultimately related to healthy methylation. But one of the interesting things about Lyme, at least a portion of it, is that there's this chronic inflammation that just continues sort of relentlessly. And there are these compounds called SPMs. They come from omega-3 fatty acids. They come from fish oil. So we've got omega-3 fatty acids in our body, in our lipid membrane. And these SPMs are little derivative molecules that we can make from these omega-3s. And these guys, their role in life is to quench inflammation, is to stop inflammation in its tracks. And in so doing, the thinking is that these chronic inflammatory events, of which Lyme is obviously a huge one, is the failure of the body to resolve them. And SPMs are one of the main tools involved in resolving inflammation. So we think of, when inflammation starts, we think about inhibiting the various pathways, like we give aspirin or we give NSAIDs or we give curcumin and so forth to inhibit some of the inflammatory compounds. But what we want to do also is turn on those processes that quench the chronic inflammation, that tell the body, okay, you're done. And there's just some cool research out there on fish oil derived SPMs. So.
Yeah, and it's very important for those that are watching or listening. You really need a high quality fish oil.
Yeah,
Yeah.
and the reason that it actually popped into my mind is, in an animal model of Lyme disease, they were big players in resolving the arthritis.
Really?
the Lyme-driven arthritis.
Right,
Yep.
right. I'm going to throw this out at you, and I don't know if I put you on the spot, you'll just say you put me on the spot. But galectin-3, do you know anything about galectin-3 and inflammation?
No, I don't.
No? Okay. We'll go on. So for our Lyme listeners, what we really need to do is we need to make sure that we're very much supportive of our methylation processes because of the impact of our DNA on methylation and our environment. Sounds like we really need to utilize products that are very influential in lowering inflammation. And after that point, what else would you suggest to people listening?
So what I would suggest is that I think we all need to be mindful around methylation, that we all need to be supporting healthy methylation, eating a methyl donor rich diet. We all need to be including those methylation adaptogens that I pointed out, like curcumin or blueberries or rosemary or, tomatoes. The zillions of foods out there that have a balancing potential, we need to be consuming those on a daily basis. And that way we're bathing our genes and we're allowing optimal genetic expression. And this is going to impact us in multiple ways. If we're preconception, if we're thinking about having a child, this goes as much for men as it does for women, that you want to optimize your epigenome because it's going to be passed down to your child. At least a portion of it is going to be passed down to your child. And then once conception takes place and you want in utero, you want the fetus to be bathed in adequate methylation and methyl donors and methylation adaptogens, because that early embryogenesis, all of that information drives, stem cells becoming taking on the specific roles that they will in the body, and it just creates an incredible information-rich time in the body that just dictates development, and you want it to be as optimal as possible. So early on, preconception, conception, pregnancy, in early childhood. But then we also look later on in life or through the whole life journey, and we see methylation playing a huge role in whether we develop complex chronic diseases or not, or in allergies and asthma or in autoimmunity. So just really through the time points of life, we see it playing a huge role, and it's something that all of us want to be thinking about. And it doesn't need to be rocket science. And I know some of what I've said today is pretty complicated, but there are some basic habits that we can incorporate. And I've mentioned a lot of the foods, but we also want to think about not drinking enough, not ingesting too much sugar, or having too much, say, poor quality animal fat, or avoiding organics. Like, we want to eat a good, healthy, big, fresh, organic as much as possible diet. And there's all of these lifestyle factors that also impact epigenetic expression. And I'm talking about genetic, but also biochemical. That is exercising. Not too much exercise, but kind of the sweet spot of exercise for you. There's a load of really interesting research on sort of the stress response really screwing up DNA methylation expression. One of the scientists who will work with me in analyzing a study that we're running is Moshe Saf, and he put this idea on the map. So in utero exposure to high stress altered DNA methylation, but even early life stress experiences alter DNA methylation. Total life stress experiences can negatively alter DNA expression. But conversely, if you experience, a lot of support and love and at early times, but through life, that favorably alters it. And the way that it can negatively impact it is by dropping your stress threshold. So you get more stressed out readily, and it's a harder thing to deal. A smaller problem becomes harder to deal with because you're sort of pre-programmed to be reactive because of your epigenome. Now, the good news is, yep, that might be the hand you've been dealt coming into the world, but you can change epigenetic expression. Some more readily than others, but you do have the power to change it. And if you make that change through, adopting a meditation habit, or, through getting up and doing a little exercise, or eating some of the foods we're suggesting, you can, move, just correct course and change the direction of the ship of your life. And again, if your preconception, again, you're going to change the outcome of not just your offspring, but your child's kids, and on through the generations. I mean, it's really beautiful stuff.
Yeah, it's unbelievable. Whenever I learned the impact of previous generations on me, then I realized, how come I'm so crazy? Because it has.
That's funny.
And yeah, I mean, okay, this is who I am. But as you said, all of these things that you have control in, you need to look at what you have control in.
They can be empowering for us. This can be our information to be motivated to live the best life we can.
Right. And we do have control.
Let me tell you something else really interesting. So I'm a new mom.
Yay!
Thank you. Thank you. And my beautiful, beautiful heavenly baby is adopted. So I don't share her genes, but she and I live in the same environment, and we interact extremely intimately. I've been with her since the day she was born, and she's 16 months now. So we share, our epigenomes converge. Like my closeness, my being with her and caretaking her, all of these beautiful possibilities in not only setting her epigenome as rightly as possible and strongly as possible, and giving her resilience and so forth, but it's influencing me as well, my connection with her. So it's just a beautiful thing to share, the epigenetic interconnection of me and my adopted daughter.
Oh, that's so great. That's so great, because you know what you're helping her with, at some point she may pass that on to her offspring. So yeah. That's such a cool concept. Yep. So
she eats loads of blueberries, this little girl, and she actually likes curry. She's definitely a fan of plenty of methylation adaptogens, and she eats greens. Amazingly enough, at least for now, she's eating greens.
Yeah, that's okay. That's okay. I always look at little ones, and I have a granddaughter. When she was a little bit when she was younger, we used to break little pieces of food up and put it on her little high chair tray, and I always look at it, it's like feeding the ducks. You got all these little things, and we used to just put all different colors and whatnot.
Yeah. It's fun.
Yeah, and if you expose even yourself, if you really, have never liked something, you have to really wonder why you don't like it. Was that something that you just didn't have good exposure to, or wasn't it, given to you in a great environment? I don't know. But just keep trying different things and trying to add them to certain things. And I think that will be helpful. I do have a quick question for you. It sounds like having a child was on your bucket list. So that's awesome. That's awesome. Give me some ideas. What else is waiting on your bucket list?
Well, I've been talking about this study. We're about to finish. We'll be done in August, and then we're going to be analyzing data for a long time. It's a big. We're measuring 900,000 methylation sites on the genome of all the study participants, and we're looking at markers of methylation like homocysteine and S-adenosylmethionine. We're also looking at a handful of SNPs, but mostly we're focused on looking at epigenetic expression, and we're going to see whether our diet and lifestyle program that I've written about, and we can give you access to that information in your show notes. We want to see, have we made a difference? Have we influenced the epigenetic clock? Have we, cleaned up genes that might have been too methylated that could be associated with cancer? What have we done? We'll be asking these questions of the data for probably years to come. But I'm hugely excited about that. And then I intend to translate that for regular people, you know, and I've got somebody working with me because I tend to swim in the science pond. So I've got somebody who's going to just help me language it in a way that people will get it, because I think it's absolutely essential that we're all adopting some of these principles. And it doesn't have to supplant, you know, your favorite diet now. You can add them in to whatever your correct dietary program is.
Exactly, exactly. That's awesome. That's awesome. I want to thank you. I want to thank you for
Absolutely.
giving this very complicated topic a little bit more soothing way so that we can understand it, because it certainly impacts not only today, but it's going to impact everybody's tomorrow. And people who are dealing with a chronic illness, and you know, they feel like their care is top notch, etc., but maybe they haven't gotten that you know, that education or that impetus into the importance of what you should be eating. And that's where I come in. That's where Pursue Wellness comes in, because that is what we do. And working with a dietitian, Kara, who is my daughter, is probably one of the most important things that you can do, because we really need to know what foods are best and how you should be preparing it and how you should be eating. So anybody that wants more information, you can contact us at pursuewellness.us, and we'll be happy to get you in our programs or offer you some assistance. So thank you very much. Dr. Kara, it is wonderful to meet you. We have talked before, but now I get to see you. And Dr. Kara's practice is in Sandy Hook, Connecticut, and she does have some wonderful colleagues that are in her practice, and she does have a lot of support services. So if you're in the area and you need something, you can contact her. Do you have your website that they can contact you through, or do they need to call your office?
Well, if patients want to come to our practice, they can reach out via, or people, I shouldn't say patients. If folks want to come to our practice, they can reach out to us through the website, or they can call us. Website is Dr. Kara Fitzgerald, Kara, Fitzgerald.com. There's a lot of content there. We've got a massive database of recipes. In fact, you'll see the ones that are methylation approved. You can learn about our methylation study. You can read blogs on methylation. You can reach out to us and see our providers to see who you might be interested in working with. We've got a large nutrition team. They're versed in doing the methylation diet. If you're interested in trying that out, you can. We've got a nutrition residency program. So we actually have nice price points for our nutrition residents. It's just big, and it's we do lovely work here. And I have two colleagues, two medical doctors who work with me in this office in Sandy Hook and see patients as well. But we do a lot of distance consulting, particularly the nutrition team. So there's a lot happening over at the website, and you can swim over there and check it out and see if you're interested. Or give us a buzz.
Swim over.
All right. Well, thank you. I
You're
appreciate it.
absolutely welcome, and we thank you too for being part of our support team, giving our Lyme people a lot of information that they can readily use and come back and enjoy. And a big thank you.
You know, if people are, you're probably versed in it, all your community here, but we actually have a really helpful Lyme exposure, tick exposure download, like what to do if you get bit by a tick, first things first. So that's over there. If you go and root around in the site, you'll find it.
Perfect.
Or email us if you can't. All right.
Perfect. All right. Thank you again. It's been a pleasure.